Welcome to Lesson 4.5. Today we're going to talk applications of linear graphs. Learning objective for today, I can solve problems involving linear relations. Here's the introductory problem. Make sure to read that before moving on. So analyzing linear graphs is a part of life, whether you are trying to decide to buy stocks, figuring out if your blog readership is increasing, or predicting the temperature from a weather report. Although linear graphs can be quite complex, such as a 6-month stock graph, many are very basic to analyze. So the graph below shows the solutions to the price before tax and the price after tax at a particular store. So that is this line right here. Determine the price after tax of a $6 item. So if you'll notice here, price before tax, so that's where we get the $6 from. So if we go up vertically to the graph at 6, and then we go horizontally over to the Y value, we will get the price including tax. And you'll notice it's a little bit below 7, so we could say something that it's roughly about $6.80. Anything around that would probably be an acceptable answer. Now let's take a look at what would happen if we wanted a $7 item before tax, how much that would cost afterwards. So again, price before tax is where we start. So we want a $7 item. We bring that all the way up to the graph. As soon as we hit the graph, we can go all the way to the side. And you'll see here that it lands right on $8. So before tax costs 7, after tax costs 8. So now we've got another graph here. And we've got this line right here. And it says the following graph shows a linear relationship between Celsius and Fahrenheit. So if you'll notice here, we've got temperature in Fahrenheit on the bottom, temperature in Celsius on the left. So we're going to use the graph and convert 70 degrees Fahrenheit to Celsius. So now, since we're given a temperature in Fahrenheit, we start on the bottom. So we find 70 degrees Fahrenheit, which is right here at 70. And we go up to the line here, and then we go horizontal from there. Okay? And it's a little bit above 20, so we're going to say that it is about 21 degrees Celsius. So 21 degrees Celsius is roughly what 70 degrees Fahrenheit would be. So now we're going to use that same graph to convert 30 degrees Celsius to Fahrenheit. So now again, we're given a temperature in Celsius, 30 degrees, which is right here. So now we need to go horizontally over to the line here till we get to the line, then we can go vertically down to the axis. Okay, so you'll notice here it's pretty much right in the middle of 80 and 90, so we could say that it's about 85 degrees Fahrenheit. And now these are all estimations, they're not exact, but it's used to approximate what it would actually be. Now we're going to switch it up, so now we're going to go 5 degrees Celsius to Fahrenheit. So if we go 5 degrees Celsius, 5 degrees is right here, so we start at the axis and we go towards the line. Once we hit the line, we can go down to the x-axis, and we get that it would be 40 degrees Fahrenheit. Go ahead and pause the video and solve this one, and then hit play and see how you did. Okay, you'll notice that if a job pays $20 an hour, to get $60, you would have to work 3 hours. So now let's change the problem a little bit. So now we're going to make it so it's $100. So now go ahead and pause the video and see how long it would take for them to earn $100. Then hit play and see how you did. Okay, so for this one, you should have gotten that $100 is equal to 5 hours of work. So just to review here, a linear graph must have a proportional relationship between the x and y coordinates, and a linear graph is a graph of a straight line or lines.